This presentation is part of the TI in Focus AP Calculus video series. In this video, we'll discuss some technology solutions and some problem extensions for the 2017 AP Calculus exam free response question AB6. My name is Steve Kokoska, and I'm a professor at Bloomsburg University in Pennsylvania, and I'm the former AP Calculus chief reader. Here's an outline of the information presented in this video. We'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. And we'll focus on the solutions presented in these guidelines, not how the points were awarded. Now, even though this question was not calculator active, we'll consider some solutions using technology. And because the free response questions are usually very comprehensive, I'll suggest some problem extensions, additional AP Calculus questions associated with the information given in the problem. And some of these may be calculator active. In this problem, we start with a function f, defined by f of x is equal to the cosine of 2x plus e to the sine x. G is a differentiable function, and the table gives values of g and its derivative g prime at selected values of x. H is a function whose graph consists of 5 line segments and is shown in the given figure. In Part A, the student is asked to find the slope of the line tangent to the graph of f at x equal pi. In Part B, another function k is defined so that k of x is h of f of x, and the student is asked to find k prime of pi. In Part C, still another function m is defined to be m of x is g of minus 2x times h of x, and the student is asked to find m prime of 2. In Part D, the student is asked if there's a number c in the closed interval minus 5 to minus 3, such that g prime of c is equal to minus 4, and the student is reminded to justify the answer. Part A was worth 2 points, and to solve this problem, we would expect the student to first find the general derivative of f, and then we would expect them to evaluate that derivative at pi. The resulting value is the slope of the tangent line to the graph of f at x equal pi. Part B was also worth 2 points, and a reasonable way to start this problem is to first find k prime of x. In order to find this derivative, we'll have to use the chain rule. Then we'll have to evaluate k prime at pi. In order to find f prime of pi, we import our value from Part A. In order to find f of pi, well, we use the definition of the function f. And in order to find h prime of 2, we'll have to use the graph given in the problem. And the final answer here is 1/3. Part C was worth 3 points, and the solution presented starts by finding m prime of x. And to do this, we'll need to use the product rule and the chain rule. Then we'll evaluate m prime at 2. In order to find g prime of minus 4 and g of minus 4, we'll use the table given in the problem. And in order to find h of 2 and h prime of 2, we'll use the graph given in the problem. And after a little bit of simplification, the final answer here is minus 3. Part D was worth 2 points. Now, the wording of the question and the given information suggests that we might be able to use the mean value theorem to solve this problem. First, we need to check the assumptions for the mean value theorem. Since g is differentiable, that's given in the problem, then g is also continuous, and the relevant quotient associated with the mean value theorem simplifies to minus 4. Therefore, by the MVT, there is at least one value c in the open interval minus 5 to minus 3, such that g prime of c is equal to minus 4. Here are some technology solutions and problem extensions. Remember, this free response question was not calculator active, but we can still use technology to support and confirm our analytical answers and to explore other possible problems. I'll solve this problem using the TI-Nspire. First, I defined the function f, and then I simply found the derivative of f and immediately evaluated it at x equal pi, and there's the answer, -1. Now, just to be complete, I've included the symbolic derivative of f, but note that using technology, I didn't have to really produce that symbolic derivative. Here's a natural extension to part A. Find f double prime of x and evaluate f double prime at pi. To find the second derivative, we need to use the chain rule on the first term, and we need to use both the product rule and the chain rule on the second term. After a little bit of simplification, I evaluated the second derivative at pi and simplified to get -3. And this is very easy to confirm using the TI-Nspire. I found the second derivative symbolically, and I evaluated the second derivative at x equal pi to get -3. Here are a few more AP Calculus questions associated with this problem. Let's let j be a function defined by j of x is equal to f of x squared. Find j prime of x and j prime of the square root of pi. Let's let L be a function defined by L of x is the log of f of x. Find L prime of x and L prime of pi. And finally, let S be a function defined by S of x is the sine of f of x. Find S prime of x and S prime of pi over 2. I think that students should be able to solve each of these problems analytically, but they should also be able to use technology to confirm their results. There is no very fast, efficient way to use technology to solve Part B. However, I can use the TI-Nspire to define h as a piecewise defined function and to produce the graph of h. To find the equation for each piece, I used the graph of h given in the problem. Each piece is a straight line, so I found the slope in the equation over each interval. And to check my definition, here's a graph of h. And I added the grid lines for clarity, and so that my graph looked very similar to the one given in the problem. In Part C, I'm just going to suggest a nice problem extension. Let's let n be the function defined by g of -2x divided by h of x. And let's find n prime of x, and let's find n prime of 2 also. In order to find n prime of x, students will have to use the quotient rule and the chain rule. And in order to evaluate that derivative at 2, they'll have to use both the table and the graph of h. This is a nice extension. And when I did all the simplification, I got a positive 3/4. In Part D, even though I don't have an explicit formula for the function g, I can still use technology to visualize this problem. First, I plotted all of the points given that are on the graph of g, and then I constructed a line joining the points -5, 10 and -3, 2. And then I used technology to find the slope of the line connecting those 2 points. Now, I still need to use some theory here, the mean value theorem, in order to answer this question. But this graph at least provides some context and a visualization of the quotient, and it might help to suggest the use of the mean value theorem to answer the question. Here's one more AP Calculus problem extension associated with this question. And really, all 4 of these questions involve the function capital H. And this is defined to be the definite integral from 0 to x of the function little h. And the graph of little h is given at the very beginning of this question. First, let's find the values h of 3 and h of -3. Then find the intervals on which h is both increasing and concave up. Find the critical numbers of h and classify each as a relative minimum, a relative maximum, or neither, and justify your answer. And finally, find the absolute minimum and the absolute maximum value of h on the closed interval -5 to 5. I hope this video gives you some good ideas for additional practice AP Calculus exam type questions and of how to use technology to solve at least some of the parts of this problem, and also to explore, confirm, and visualize results. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology, of course, calculus, and many other mathematics topics.